Hello, this is Maria from Math Mammoth, and this is Matty, my mascot. In this lesson, we are looking at scientific notation for very small numbers. And this is based on using negative exponents. Here on the screen, you see the definition for negative exponent. If we have a number like a raised to the power of negative n, then the result is a fraction, 1 over a raised to the positive exponent. And that allows us to use very small numbers because it's a fraction. Let me show you an example. Here we have 10 raised to the power of negative 6. And it becomes 1 over 10 to the 6th, or 1/millionth part. As a decimal, 0.000001. Here I have a pretty small number, wouldn't you say? And in scientific notation, it becomes like that, with a negative exponent. Next, we're going to practice this and write numbers that are in scientific notation, in decimal notation, and then also vice versa. Let's look at some examples now. First of all, if I have, let's say, 8 times 10 to the power negative 2. So what does this become? 8 times 1 over 10 squared, right? And this here is 100. So we actually have 8 hundredths. And as a decimal, it is 0.08. Now notice, we have this exponent here, negative 2. And here we have 2 decimal digits. And the 8 becomes the second decimal digit. Now, with this one, the exponent is negative 4. Okay, so that makes it 1 over 10 to the 4th, or 1 over 10,000, a 10,000th part, and 6 of them. So we would get 6 times 1 over 10,000 as a fraction, but as a decimal, we can think of a shortcut. It will be the 4th decimal that will have the value 6. Okay, 1, 2, 3, 4. See, this is 10,000ths. Here we have tenths, hundredths, thousandths, and 10,000ths. Next, 5 times 10 to the power of negative 9. Can you do it before I get to writing it? 0 point, and then the 9th decimal place will have 5. All right, with this one we have the decimal point here, followed by 0.98. But it still works that this first 8 here will be in the 7th decimal position after the decimal point. Let me show you. I better start somewhere here. So the 7th decimal place will have 8. And then this, and then the rest of the digits. Naturally, the scientific notation is much handier than writing out these kind of long numbers, but we are just practicing. Want to try that on your own, on paper? Pause the video, okay? All right, so 11th is that one, and then those. Now let's try it the other way. Write these in scientific notation. Here we have 1, 2, 3, 4. This is in the 10,000th place. Okay, so our exponent will be negative 4. 9.4 times 10 to the power of negative 4. Here, 1, 2, 3, 4, 5, 6. So 4 is in the millionths place. That means the exponent will be negative 6. And we will take all those digits, put the decimal point here, because this multiplier, this coefficient, has to be between 1 and 10, just like with the large numbers. And then times 10 to the power of negative 6. All right. Now our task is to compare the two numbers. Which one of them is greater? Think about it. Once again, try to solve it on your own. This one here, we could write it in scientific notation and then compare. Or we could write this in a decimal notation and then compare. But let me do the former. This one will be 4.5 times 10 to the what? It's the 4th decimal, so negative 4. And now it's easy to see that this here is the greater number. Here we have two numbers written incorrectly in scientific notation, and our task is to fix them. If you remember, once again, this multiplier has to be between 1 and 10, not 800 something or 0 point something. With this one, we need it to become 8.03. And so changing it from 800 something to 8 something, I am doing a division by 100, right? That means that this other number here will gain times 100, okay? Or times 10 and 10. So I basically have 10 to the power negative 12 times 10 squared, or the 100. And now I can add the exponents, negative 12 plus 2, and I will then get 10 to the power negative 10, and this multiplier here. Did you get the same? This one goes just the other way. We need it to be 9.1, so it needs multiplied by 10. What happens to this one then? Okay, if this gets multiplied by 10, or did get multiplied by 10, then we actually have here multiplication by 10 to the negative 1, or 1/10. It actually is a division by 10 to compensate. So then this becomes 10 to the power negative 7 in the end. Okay, we got both of them fixed, and I hope this was helpful.